Hey guys, Brent here from VoodooJs, and this screencast is an introductory tutorial for using Voodoo. It's the first screencast, and we're going to cover some basic concepts today, like the model and view base classes, using Three.js to load geometry into our scenes, aligning 3D elements with 2D elements, some coordinate systems, and events at the end. Our example today will be a 3D animating clock. And you should be able to take this clock and use it on your own websites if you'd like at the end. The hope is that after this video you can go off and create your own 3D controls. Now do keep in mind Voodoo is still in beta, so some of the API could change between now and version 1.0, but hopefully not significantly. So with that out of the way, let's get started. So we'll start with a very basic web page. It pretty much only has a title on it. And we're going to create everything from scratch today, so you can see the whole process step by step. The first step we'll want to do is link in both Three.js and VoodooJs. Now, in case you don't know, Three.js is the 3D engine powering Voodoo, and Voodoo is the framework on top of Three.js that lets you mix 2D and 3D together. And you need both, and it doesn't matter which order you link them, so we'll load them both. We'll also want to create a separate JavaScript file for our clock control. And the reason this is a good idea, and you don't have to, but it's a good idea, is because then you can share this JavaScript file with anyone else and they can drop your controls onto their pages easily. So we'll do that. Call it clock.js. So let me talk a little bit about the general structure of a 3D control. Every 3D control you create will have both a model and a view to it. Voodoo provides the base classes, and it's up to you to extend them and implement what you need. Now, the model is what the user instantiates when they want one of your controls, and it generally stores the state of your control. Now, the view, on the other hand, is the container for all of your geometry and materials and everything the user actually sees. That gets loaded and unloaded in the view. Now the model and view do talk to each other, so the view might ask the model for settings, and the model might tell the view how to update. So let's create a view called clock view and a model called clock. And when we create our model, we have to give it a name because Voodoo uses this for debugging. And we also have to tell it about the view, so we'll do that now. Okay, so at this point we have the bare minimum for a control. So let's instantiate it and see what happens. So the first thing to note is we don't see anything on screen, but if we open up the console, we can see a lot is going on. First, you see that Voodoo tries to instantiate our control, but then it realizes that an engine hasn't been created yet, so most of those messages below are creating the engine. Then at the bottom you can see a couple lights were created, and that's part of the Voodoo standard lighting model. So it's quite nice, all this is taken care of for you if you don't set up an engine yourself. Now getting back to our clock, I'm going to override two functions in our view. The first is load and the second is unload. Load is used to create and add geometry to our scene, and unload is used to remove that geometry. The first geometry we're going to create is a cylinder clock base. It'll be a circle that the hands will sit on top of. And to do that, we're going to use some Three.js functions. Now, all of the functions we're calling here you can read about on the Three.js documentation page. It's quite nice. But the gist is we're creating a red material, so our clock base is going to be red, And we're creating a cylinder geometry in unit space, which we'll talk about in a sec. And then we're creating a mesh that combines both the geometry and the material into a renderable object. Then now we add that mesh to our scene, and we also remove it from the scene in unload. Of course, nothing is displayed yet, and that's because the cylinder is in unit space. So what I'm going to do is position it first at 500 pixels by 500 pixels, and then scale it up so that it has a radius of 100 pixels. And there it is. It looks pretty good, except it's all flat color, so let's change the material to a mesh Lambert material. And what that does is it takes into account the normals of the geometry to give it a smooth lighting across the surface. We'll also color it gray. And that looks a little better. But there's another problem, and it's that it's facing the wrong direction. So let's rotate it 90 degrees along the x-axis. Math.pi/2 is 90 degrees in radians. We'll also change the depth so that the clock base is 50 pixels off the page. And now would actually be a good time to explain what we're doing here. So as soon as we see what it looks like, I'll take a break and show you that. Okay, it looks pretty good. It's a good looking clock base. So let's talk about coordinate systems. On a typical page, you'll have both x and y coordinates in pixels. They start at 0, 0 at the top left corner of your page. Hopefully this is nothing new. And the x goes across and the y increases down. Now in 3D, objects have a z. And with Voodoo, this refers to the number of pixels off of, in front of, or behind the page. So positive z values describe content above the page, above the 2D content, and negative z values refer to content that's behind or below the 2D content. This is sometimes called a right-handed coordinate system. Another concept worth mentioning now is the idea of creating your initial geometry in unit space. And what this means is that coordinates along the x, y, and z dimensions range from -1 to +1. Now, this means that when you create your objects initially, they're positioned at the very top left corner of the screen and they have almost no size. But the reason this is useful is because you can set the position and scale values of your mesh arbitrarily, and your geometry will move to wherever you want it on the page. What we're going to use this for is aligning our geometry to fit inside of a div. So we're going to create a 2D div somewhere on the page and then move our 3D geometry on top of it. And positioning your objects this way is just very intuitive to the user. Now, getting back to our clock, we're going to do two things. The first is we're going to make the color of the clock base configurable by the user. And the second thing we're going to do is we're going to allow the user to attach our clock to a div. Voodoo lets you pass an options object into your constructor of your model. So what we're going to do is we're going to set the color to, let's say, red again. And this options object gets passed to your model during initialize. We don't have initialize yet, so let's create that now. And options is this options object. We're going to store our color for now, but the first thing is the color coming in is a CSS color. Red is a CSS color name. So Voodoo has a utility function called convert CSS color to 3JS color, and we're going to use that here to convert our friendly name into something that our view can understand. Now inside our view, we can change the material color to be the value that's inside the model. And we also don't need to set the color anymore arbitrarily inside the constructor. So let's take a look at what this looks like. There we go. It's red, and let's just see, what if we change this to, let's say, gray again? Okay, and we get our gray clock back. So this is great for letting the user control properties of our controls. Let's apply the same idea and let the user set a div. So the first thing we need to do is we need to create a div in our HTML, and we'll call that clock, and we'll say it's a width of 200 pixels by 200 pixels, and just for the sake of showing where it's located, we'll set the background color to black. And let's add some space between the title and our div, just so they're not right up against each other. So let's see what that looks like. Okay, so that's where we're going to put our clock. Now, we'll want to pass in this div to our model so it is able to access its location. So now inside the model, going back to initialize, we'll save our element, and we'll override a second function in the model called update. Now, update runs every frame, which means it's running constantly, and this is perfect for positioning our 3D controls in real time. So the first thing we'll do is we'll get the position of our element. Voodoo has a utility function to get the top left corner of the div relative to the top left corner of the page, called find absolute position. So we'll use that, and then we'll pass the position and also the size, the width and height of our div to a function in the view that we're going to create called move. So let's create that now. Now move is our own function. It's not one that we're overriding from the view, and Voodoo lets you do this. You can write your own functions and call them from the model and view. And what we'll do is we'll change the X position and the Y position of our clock base to be in the center of the div. Now we also need to change the scale, the size of our clock base, and what we'll do is we'll set it to half the width and half the height. Now we're setting it to half the width and half the height instead of the full width and the full height because remember, our coordinates for the base range from -1 to +1. So if we multiplied by the full width and height, then our clock would be double size, which wouldn't be good. So let's see what this looks like now. Okay, cool. So it looks like our clock base is correctly centered right on the div. So let's see what happens if we were to change our size to say 300 by 300. What would happen? And great, it looks like our clock instantly got a little bigger, which is perfect. So let's go ahead and remove the background color that's black. We don't need that anymore. We'll just use the div to position our clock. So things are looking pretty good, and now's a good time to create our clock hands. I realize this next section might get a little confusing, so I just want to talk for a second about what we're going to be doing. In this picture you see our circular clock base in unit space from -1 to 1, and the green rectangle represents the future hour hand that we're going to create. Our hands will be rectangles, and you can sort of get a sense of what the coordinates might be by looking at this picture. Now the hour hand will kind of be short and fat, and the minute hand will be a little skinnier and a little longer, and our second hand will be even skinnier yet and even longer yet. The first step is to build the geometry for our hands, and unfortunately there's no clock hand geometry that Three.js provides, or any other geometry that I could see that we could easily adapt to this situation. So instead, we're going to create our own. We'll call this function createHandGeometry, and it'll take two parameters, a width and a height, in unit space. So, for example, if our height was 0.5, that means that our clock hand would be half the radius of our clock. The details here are kind of mundane and uninteresting, but basically we're creating 4 vertices, 4 points, representing the 4 corners of our clock hand, and then we're going to create 2 triangles, 2 faces, that connect these vertices to make a rectangle. And this is standard practice in 3D. So then we'll return this geometry back to the user. Okay, great. So now that we have our helper function to create hand geometry, let's use it to create a hand mesh. And the mesh is what gets added to the scene. So first we'll create a material. We'll have our hand for now be red. And then let's create some geometry using our helper function. These sizes will be sort of arbitrary. And then let's combine our geometry and material to make a mesh. Now we'll add that mesh to our scene. And similarly, we'll remove it from our scene in unload. Now right now our hand is flat on the page, so let's give it some depth. We'll raise it above the surface of the clock base. We'll raise it a little bit higher. And I just realized that we don't need to be setting the position anymore up here and scale because we do it in move. So let's also update our clock hand's position and scale. So this matches, remember this matches with the div's location and sizes. That should be good, so let's see what it looks like. Perfect. There's our clock hand. Very simple. So let's see if we can generalize this. First, we'll create a load hand function, and what this will do is it'll let us pass a width and a height and a color and a depth, and it'll build the mesh and add it to the scene and then return it to us. So we'll create an array containing all of the hands, and we'll push each one into that array as we create it. The first one will be the hour hand, and it'll be sort of wide and not that long, and we'll color it dark gray. And then we'll also create our minute hand and second hand as well. Our minute hand will be a little skinnier, and our second hand will be even skinnier yet, and our minute hand will be a little longer than our hour hand, and our second hand even longer yet. And for the colors, our minute hand will be sort of medium gray, and our hour hand will be red. So let's actually fill in that load hand function. We'll base it off of that hour hand we just created. Set the color and the width and the height. And since we're not saving it, let's remove the this. And let's set the depth. Perfect. Since we have an array, let's remove all three hands on unload. And let's do the same thing in our move function. So this looks pretty good, but of course we want our clock hands to actually show the real time. What we'll do now is create a new function called tick. And tick will take three angles: an hour angle, a minute angle, and a second angle. These three angles will be from 0 to 2 pi and will represent how far rotated each hand is around the axis coming out of the center of the clock towards you. That's the z-axis. And we'll call this function from update. Just like move, every frame will update the angles of our clock hands. So to do that, let's get the current date, and because the date lets us get the amount of seconds and hours and minutes. And for the hour hand, we'll take the current number of hours, divide it by 12, so now it's a value from 0 to 1, and then multiply it by 2 times pi, so our range is from 0 to 2 pi. And we'll do something similar for the second hand and the minute hand. Except for the second hand and the minute hand, instead of dividing by 12, there are 60 seconds and 60 minutes, so we'll divide by 60. So let's see what this looks like. Oh, there we go. Great, so this clock looks pretty good, and it's pretty much exactly what we set out to do. You wouldn't need to do anything more than this if you were creating a control, but since this is a screencast, let's go over a couple other things you can do with Voodoo. The first is that you might want to reuse this clock multiple times on the same page. So let's see how you could. Now remember, our first clock was based on where a div was located. So let's create a second div for our second clock. We'll make this one a little larger. Shrink the first one down. And let's create the actual div itself. Now here's the great part. Now that we've created this reusable control, it doesn't take much work at all to actually instantiate another clock. Let's copy the first one. All we have to do is tell it that it's a different div, and let's change the color. And there we go. Very easy. Another thing you might want to do with your models is make them clickable. And Voodoo provides a very simple function to register for events like click and mouse move, and it's on. It's called on. It's part of the model. So we can say on click, call this function. So for the blue clock, we'll just pop up a message box telling the user that they clicked it, and we can see what happens. Oh no, there was no message box. The reason for that is because we didn't add any triggers. Now a trigger is, it tells Voodoo what parts of your view are clickable. In this case, we don't want to make the clock hands clickable, that doesn't matter, but our clock base can be clickable. So we'll add a trigger for the clock base and then remove that trigger and unload. And now if we click it, we get our message box. A third thing you might want to do is extend your own models. Create derivations of models you already created. So let's demo this by creating a blue clock. And this blue clock will be extended from our clock that we already created. So we'll say clock.extend, just like we did voodoo.model.extend, but now it's our own model. And we'll override initialize so that whatever options the user provided, they always get a blue clock. Okay, and we need to make sure to call our base classes initialize. So we'll pass in the options that we just modified. And we get the same thing, but now our second clock is called a blue clock instead of just a regular clock. So that's the end of this video. Just want to say thanks for watching, and especially thanks to the folks over at VoodooJs for making this whole project possible. It's really amazing all the work they're doing over there. If you like the screencast or have any questions about it, feel free to comment below. I'd love to hear from you. The source code for this demo will be posted at VoodooJs.com. You'll find it on the blog and also in the Learn More section. And I'm just excited to see all of the cool, interesting projects that you guys will come up with. So thanks for watching.